Welcome. My name is Jerry Soonering, and today's lesson will look at how can I use what I know about fractions to solve real-world area problems. Before we get into today's lesson, we're going to look at some pre-required skills that students may need to look at in order to understand this lesson fully. When we're going to be multiplying by area, we can allow students to think about changing a mixed number to an improper fraction. When we're doing this, we want to have them practice the routine of, in order to get the numerator and denominator. The numerator is when we multiply the denominator with the whole number and add the numerator to that answer. So if we look at this example, if we have a mixed number of 3/4 and we need to get our improper fraction, the way we get our 14 is 4 times 3, which is 12, and we're going to add the numerator, which is 2. 4 times 3 is 12, plus 2 is 14. And then the denominators stay the same. We're not going to change it. Here it reiterates this. We're going to leave our denominators alone. So we want students to practice multiplying the denominator with the whole number and then adding the numerator to get the numerator of the improper fraction. So here 3 times 5 plus 1, 3 times 5 is 15, plus 1 is 16, and our fraction would be 16 thirds, or 16 over 3. Last example, we want students to understand we're going to multiply 5 and 8, giving us 40. 40 plus 2 is 42 and gives us our improper fraction. The next slide is going to be another additional resource to help students. So when we're multiplying fractions, for example, let's say if we have multiply 5 1/3 and 2 2/3. When we're multiplying it, we want to convert the given fraction to improper fraction. We're going to multiply across and then turn back into a mixed number. So when we do this, the first thing we're going to do is convert the mixed number into an improper fraction. So we did that over here with these two fractions. Then we're going to multiply across. So we have 16 thirds and 8 thirds. We put those values here. We're going to multiply across. 16 times 8 gives us 128. 3 times 3 gives us 9. When we do this, to convert an improper fraction into a mixed number, we want to make sure that we have 128 divided by 9, which I did that over here. We know that 9 goes into 128 14 times with a remainder of 2. These two numbers are going to be very important to go back into our answer. The 14 will be our whole number, the 2 will be our numerator, and we know that the denominator does not change. Providing students with the support can be very helpful for converting mixed numbers into improper fractions and also multiplying fractions and the steps that's required of it. We're going to look at two problems that look at doing this. Problem 1. George decided to paint a wall with 2 windows. Both windows are 3 1/2 feet by 4 1/2 feet rectangles. Find the area of the paint needed to cover. So when we're looking at this problem, we have a wall, which is the white space here, and we have 2 rectangles. These would be the windows. So we want students to understand that we want that George will need to paint everything except the windows because we're not painting the windows. So how would we go through this problem? Okay, on the next slide, I provided step-by-step guidance on this. So the first step is we need to find the area of the wall. The next step is find the area of the windows, and then we're going to subtract the 2 values to get our answer. Over here, what I've done was to convert the mixed numbers, and then we're going to multiply it, and we're going to convert these mixed numbers into improper fractions. So I see 12 7/8. We converted that, as well as these 2 values, 3 1/2, and 4 1/2 into this. So the first thing we're going to do is find the area of the wall. So here, I'm going to take my improper fraction that I changed. We're going to multiply it by 8, length times width. Then we multiply across, and we get 103. Next step is we're going to find the area of the windows. This one's going to be a little bit tricky because when we multiply, as we see here, 7 halves and 9 halves, we get 63 over 4. We're going to multiply by 2, and that's going to be very important because we have 2 windows. If I just found 63 over 4, that only tells me the area of one window, so therefore I need to multiply by 2. I put 2 over 1 because we're going to multiply across, numerator times numerator and denominator times denominator. When we do this, we convert it, and we're going to get 126 over 4, and when we convert that, it's 31 1/2. So that tells us that the area of the window is 31 feet 1 1/2. Next, we're going to take those two values and we're going to subtract it. And here, what I did was, here it says 102 over 2. I just took 1 away from 103, giving us 102, and I took that 1 and turned it into a fraction. Therefore, we're going to subtract whole number and fraction by fraction. So here, when we subtract the whole number, we get 102 minus 31 gives us 71. And when we're subtracting fractions, especially our numerators and denominators, the denominators stay the same, while our numerators we subtract. 2 minus 1 gives us 1. Therefore, the area George will need to paint is 71 1/2 feet squared. And don't forget about the squared because we are talking about area, and that is very important when we're talking about our units. Next, we're going to be looking at problem number 2. In problem number 2, Joe uses square tiles, some of which he cut in half to make a figure picture to the right. If each square tile has the side length of 2 1/2 inches, what is the total area of the figure? So on the next slide, we're going to provide some guidance on how to work through this problem for our students. So here, the first step, but before we get into our first step, we have some reminders. We want to remind students that squares, all sides are the same, the length and width are 2 1/2 each. So if we know that one side is 2 1/2, then all the sides around it is the same value. We also notice that this figure is made up of 2 half squares. So if these are 2 half squares, if we combine it, it equals 1 whole square. So again, what we're going to do is, first step is we're going to count the number of squares. I put 10 plus 3. There are 10 complete squares here, and there are 3 half squares. So this would be 1, this, and this would be 2, and this would be 3. Therefore, we have 10 plus 3 is 13. Next, we're going to find the area of each square, which we converted 2 1/2 to 5 halves. We got the answer here. And then we're going to multiply the number of squares times the area of the square. So the previous two answers, we multiply, we get 81 1/4. So the total area of the figure is 81 1/4 inches, and don't forget the square. So inches squared. Now we're going to go into our summarization. How can I use what I know about fractions to solve real-world area problems? What we can do is, knowing how to convert between mixed numbers and improper fractions, understand the rules of fractions, for example, adding, subtracting, and multiplying. These are going to be rules that will be very important and reinforced, especially in this lesson. And lastly, read the word problem to develop steps to arrive at the solution. Hope this was helpful, and have a great day.